Welcome to this explainer. Today, we're focusing on something absolutely crucial for anyone diving into the world of digital research, and that is building a rock-solid investigation plan. Look, whether you're stepping into cybersecurity, journalism, law enforcement, or corporate intelligence, you literally cannot just wade into a sea of data haphazardly. You need a structured methodology. Okay, let's dive into this and look at exactly how professionals turn raw information into actual, actionable intelligence, right from the ground up.
Here's our roadmap for today. We're going step by step through the intelligence lifecycle. We'll start by defining OSINT, moving into triage and goal setting, prepping our workspace, checking out tools for collection, and then we'll wrap up with ethics, archiving, and defensive countermeasures.
All right, Section 1, Defining OSINT. Let's get our foundational concepts straight before we do anything else.
So, OSINT stands for Open Source Intelligence. Simply put, it's the highly structured process of gathering and analyzing information from sources that are publicly accessible to anyone. We're talking about websites, social media platforms, government records, news articles, the whole shebang. But here's the absolute most important part. This is done without violating legal or ethical boundaries. You know, government agencies might combine OSINT with secretly acquired classified data, like intercepted comms or satellite images. But our focus here today is entirely on what can be legally, openly accessed by the public.
Moving right along to Section 2, Triage and Mission Goals. This is where we establish the mission.
Investigations almost always kick off with an intake request. You might be asked to conduct a threat assessment on someone making online threats, or maybe an assessment for a massive upcoming event. You could be tasked with building a target profile for corporate due diligence, doing some account attribution to figure out who's actually behind a malicious domain, or even running a vulnerability assessment on your very own organization. But no matter what the mission is, your first action is always triage. Depending on how urgent things are, you might have 30 seconds or 30 minutes to pause and calculate a deliberate plan of attack. The golden rule: never just bushwhack your way through the internet.
Now, what's really interesting about this slide is the fundamental truth it highlights. Just finding data isn't your actual goal. Information on its own is just raw data. It honestly doesn't become intelligence until it has context. If you ask a professional analyst what their very first step is, they'll tell you it's identifying the core question: what do we actually need to know? Taking the time to articulate your investigative goals up front is exactly what gives your collected data its meaning.
And that brings us right to the formal open source intelligence lifecycle. This is a highly repeatable workflow used by the pros to guarantee accuracy and efficiency. It starts with planning, which is what we're doing right now. Then you move to collection of the data, processing it into a usable format, analyzing it to find that crucial context, disseminating your findings in a clear report, and finally getting feedback. Following these exact steps ensures your investigation remains totally focused and legally defensible.
Section 3, Preparing your workspace. Let's talk about setting up your environment for success. There's this brilliant practice called gnawing. Think of a surgeon walking into an operating room. Their instruments aren't just thrown in a drawer. They are sanitized, organized, and laid out perfectly logically. Well, investigators need to do the exact same thing with their digital workspace. Before you even type a single search query, you create your investigative folders, set up your digital notebooks, prep your legal pads, and boot up a clean virtual machine. If you're unfamiliar, a VM is essentially a secure, temporary computer running inside your actual computer. You need this sanitized environment ready to capture evidence systematically.
Of course, how deep you go into this preparation depends heavily on your timeline. Let's compare two extremes to put this in perspective. If you're handling a 20-minute threat assessment, say someone threatening self-harm in a live chat room, urgency dictates that you might have to compromise on deep operational security, or OPSEC, just to rapidly gather situational intelligence. OPSEC being the practices that keep your own identity hidden. But what about a 20-day undercover investigation into a criminal enterprise? That requires complete isolation, dedicated mobile devices, incredibly strict OPSEC, and carefully managed accounts so the platforms themselves don't flag your investigative behavior as suspicious.
Section 4, Tools and Collection. This is where we start gathering the actual data. Interestingly enough, we can learn a lot from how cyber attackers plan their intrusions. What you're seeing here is the MIT ATT and CK matrix. It's a globally recognized framework mapping out how cyber attackers operate, focusing specifically on the reconnaissance techniques. Attackers will methodically map out network infrastructure, active IP addresses, domain properties, and targeted users before they ever make a move.
As investigators, we use these exact same mapping concepts to understand our targets, just for defensive or analytical purposes instead of malicious ones.
And this brilliantly illustrates the sheer scale of where we can look. The OSINT framework maps out 32 different categories of search objects. The landscape of queryable public data is just incredibly vast. We are talking everything from email addresses, domain names, and IP blocks, all the way over to malicious file analysis and public business records. It's like a giant puzzle waiting to be solved.
To successfully navigate that massive landscape, investigators have to map specific tools to their specific intelligence requirements. For example, let's say we're investigating a cyber event, and we've got an attacker's email with the username R03bud. We don't just use one tool and call it a day. We might take that username and run it through Have I Been Pawned to see if it pops up in any leaked credential databases. Then, we might use Shodan to scan for open ports associated with their IP address. We can use ZoomEye to pinpoint a device location, and a tool like Spiderfoot to aggregate the whole thing. The real magic happens when the data from one tool feeds directly into another, creating a highly synergistic, comprehensive intelligence picture.
Now, during collection, you also have to verify the authenticity of what you're looking at. A totally critical piece of this puzzle is EXIF data. This is the hidden metadata embedded right inside image and video files. EXIF data can actually reveal the exact make and model of the camera that took a photo, the precise time it was taken, and crucially, specific GPS coordinates. It's an absolutely incredible source of truth for geolocating targets.
Let's move to RRS and see how this builds into the bigger picture. By taking those digital clues, like the XF data, domain registrations, or even visual landmarks from social media videos, investigators can visually map out events, verify physical locations, and establish undeniable connections between seemingly totally disparate pieces of information.
Section 5. Ethics, Archiving, and Documentation. Let's talk about our legal and moral responsibilities here. A truly effective open-source investigation is constantly anchored by these three core ethical questions. What do we need to know? Why do we need to know it? And who might have it? You have got to always justify the intent of your search. Look, just because information is public doesn't mean you should just randomly compile it without a legitimate, thoroughly documented reason.
The seriousness of the situation entirely dictates your scope of engagement and your level of intrusion. For instance, if you're asked to assess a vague threat made against a public official, your scope is generally pretty narrow. You check the specific public profiles involved, make the assessment, and stop there. But if you're investigating crimes against children, the scope becomes incredibly broad. In that scenario, you're ethically and professionally compelled to exhaust all reasonable digital means to ensure public safety. In both of those cases, you obey the law, but the scope of your effort scales directly with the severity of the threat.
And honestly, whatever you find, you absolutely must secure it. You cannot just rely on a web page remaining online forever. Targets delete their accounts, sites get taken down, it happens all the time. So you have to maintain a strict chain of evidence. That means capturing full-page screenshots, documenting URLs, using encrypted storage, and adhering to privacy laws like GDPR in Europe or CCPA in California. Major organizations like Bellingcat and the Syrian Archive have established true gold standard processes for this, proving that securely archived open-source evidence can even be used in court to prosecute serious human rights violations.
Section 6. Defensive countermeasures, bringing it full circle to protect our own organizations.
So, the crucial point is that organizations can and absolutely should defend against the very OSINT techniques we just learned about today. You have to minimize your footprint, configure intrusion detection systems, think of them as digital tripwires, to catch unauthorized scanning. Limit the amount of sensitive info exposed on your external portals. Continuously train your employees to spot social engineering, and proactively register domains that are similar to your own so malicious actors can't use them for phishing scams. Proactively auditing your own digital footprint with these OSINT tools is hands down the single best way to secure your perimeter.
Well, we've covered a ton of ground today, from the absolute first principles of triage and planning, all the way to secure archiving and defensive tactics. But I want to leave you with this final, really vital thought to chew on. As OSINT tools become exponentially more powerful and public data grows more and more abundant, how do we actually balance the absolute necessity of open-source investigations with our growing, completely valid expectation of digital privacy? It's a really complex line to walk. Next time, we'll dive even deeper into protecting your own identity while researching, as we tackle operational security or OPSEC. Thank you so much for joining me on this explainer, and hey, keep that workspace organized.